In the last video, we talked about the proof of work mechanism, and the issue we have, the power consumption problem. Several attacks are possible, and the future, we know that the kind of computational power is needed in the POW. There are the basic need for providing some alternatives of POW. So we have two mechanisms, that is proof of stack and proof of bond, for today's discussion. And one more mechanism I will discuss in very brief, that is proposed by Intel, and it needs hardware support also. So the basic idea in proof of stack or in proof of bond is like in POW, proof of work, lots of the computational power is needed to complete the challenge, to solve that challenge. And in proof of stack, in proof of bond, this very condition, the basic requirement of the computational power is ignored, and another alternative suggested. Like in proof of stack, how much amount a miner have, according to that, the probability of the block proposal is granted. And in the proof of burn, how much amount he actually burned, according to that, the mining probability is granted. So let's discuss this proof of stack. It was proposed in probably in 2011, and it was proposed in a Bitcoin forum by a member, and this is the link for that, you can explore. And that member proposed a proof of stake mechanism, and the forum felt that now this is the time to transition from proof of work to proof of stake. And definitely in the proof of stake, any miner will require some Bitcoin. So definitely he have to participate in POW network to collect, to earn some Bitcoin, and then he can participate, or he may purchase some Bitcoins. So in POW, probability of mining a block depends on the work done by the miner. So if, just one second. So in proof of work, the probability of mining a block depends on how much work a miner is doing. But in proof of stake mechanism, say a miner have 1% of Bitcoin, then the POS network will allow 1% of the POS blocks only. That is, the amount of Bitcoin that miner holds, in that ratio only, that miner will be allowed for the proposal of certain blocks. So this idea basically helpful to avoid any kind of monopoly, and reduces the power consumption, which is the major issue with the proof of work mechanism. Now, the proof of stake mechanism provides increased protection. Suppose any attacker attacks on the PoS network, then attacker will need some Bitcoin. And no one would like to use the Bitcoin unnecessarily. So attacker will need more Bitcoins, and the attacker needs to own majority of Bitcoin for that, because for each mining process, the Bitcoin will be used and it will reduce the incentive for attacks. But this traditional approach of the Bitcoin, the traditional approach for the proof of stake have some disadvantage also, because if someone have more Bitcoin, then he can do major portion of the mining. So some variants of the stack is proposed, like in NXT and Black Coin, a kind of randomization in combination with stack is used. So just like in earlier example that suppose 1% you have, then 1% of PoS block you can add. So not exactly that. So a kind of randomization function we can apply with the stack, and then we can use. So it is used in NXT and Black Coin. Another variants we have in peer coin, and here number of coins multiplied by the number of days the coins have been held. The basic advantage of this idea is, suppose someone wants to attack on a network, then he may purchase some Bitcoin, performing attack, and then he may expend all those Bitcoins. But by using this mechanism, the attacker have to hold all those Bitcoin, then only it would be possible for addition of the block. So this is the good solution, good variants for the proof of stake. Next one, we have proof of burn mechanism. Here, miners should show proof that they have burned some coins. So this is the different one with the proof of stake. There, the proof of stake means the ratio of the stack decides the addition of the block. Here, miners should show the amount, the coin they have burned. Send them to, basically, they will send them to a verifiable, unspendable address. And it is also expensive, just like PoW, but no external resources are used here. Here, the burned coin is the idea, not like the computational power we use in PoW. So we can say that in PoW we use real resources, but in the PoB, that is proof of burn, a virtual resources is used, that is a burnt coins. Now, PoW works by burning PoW mined cryptocurrency. And this is the interesting one. Definitely in this network, if someone wants to participate, then definitely he needs some coin, some Bitcoins. And that Bitcoin will be by mining of the PoW mechanism. So that is, it This POW can work only by using the POW mined cryptocurrency, and then he can burn and then he can participate. So if we summarize our comparison of the POW, POS, and POB, that is proof of bond. In POW, we do some work to mine a new block and consumes physical resources like CPU power and time. And POW basically it's a power hungry game. Jabki POS, that is proof of stake, and proof of bond, both are power efficient. In proof of stake, acquire sufficient amount of Bitcoin to mine a new block, consumes no external resources, but participates in transaction, and it is power efficient. In proof of bond, we have to burn some wealth to mine a new block. So it will resist the unnecessarily attack on that. But this proof of bond consumes virtual resources, not like virtual resources like coins, not like the physical resources, as I said. And I said it is power efficient. The last one, this is the proof of elapsed time, PoET. This was proposed by Intel as a part of Hyperledger Sawtooth, which is a blockchain platform for distributed ledger application. And the basic idea here is each participant in the blockchain network waits a random amount of time. So for mining, the miner have to wait for some random amount of time, and the first participant to finish become the leader for the new block. But here the problem is how we can be able to find out that he is the genuinely waited for some time. So to verify that the particular proposer has really waited for a random amount of time, a special type of hardware Intel proposed, and that is known as a Intel Software Guard Extension, kind of SGX, and it is a trusted execution platform, kind of private trusted code is used for that. So this is of the about the consensus mechanism in the open model. In the next lecture, I will start series of 3 to 4 video lecture for the permission blockchain. And permission blockchain is a totally different approach is used there, and some classical algorithms mechanism of the distributed system is used there. So enough for today. Thank you.